Deaf and hard of hearing users have long been frustrated with live TV captions. The aim of this work is to put metrics in relation with caption usability and to understand better what affects the user experience with captions. This work challenges the notion that user ratings and high caption accuracy could be the gold standard by which we can assess the suitability of caption metrics. We look both at live TV captions and high-quality offline-generated captions. Both have perceived problems, even the high-quality ones. There is much variability across how users experience captions. It is influenced by many different factors, and accuracy of captions is only one part. In the following, we will talk about the studies that we did to correlate the user experience with caption quality metrics, and explore the factors that affect the user experience of captions. We had 3 research questions. 1. What is the relationship between the user experience and caption quality metrics? That is, can quality metrics stand in for testing captions with users? 2. Are some metrics better suited than others to capture the severity of different types of caption errors? And is this reflected in user ratings? 3. What factors affect the user experience of live TV captions? Research papers out there involve discussions on 4 things, and we will emphasize on the last 2. Condensing captions from speech. Rather than verbatim, the words in the captions are condensed, which can make captions harder to understand, especially for DHH. DHH's user experience with captioning. DHH has diverse needs and preferences when it comes to non-speech information, such as music and sound effects. Latency and caption quality. Latency and caption quality go hand in hand. Latency is how long it takes captions to appear on the screen. Captioning latency affects how well people absorb the information. Studies show that if people hear the speaker and the captions are delayed, it can create frustration. Split attention effort. This means deaf people often have to split their attention between the captions and what's happening on screen. This is the reason for fatigue and makes it difficult to follow the conversation. Offline versus live captions. Offline captions are created after the fact and then added to a pre-recorded video. They are usually 99% accurate. Live captions created in real time during a live event like news, sports, or talk show. They usually have lower accuracy than offline captions and higher delays. Caption styles. Roll-up captions scroll up on a fixed screen region, typically the bottom. They are used in live TV captions in the USA. Pop-on captions are timed to appear and disappear synchronized with the audio, a few lines at a time. On the next 2 slides, you will see some example videos with both live TV captions and high-quality offline captions that we have used as stimuli in the study. You will see first the difference between pop-on and roll-up captions with high-quality offline captions. Then, you will see the same content as live TV captions versus another high-quality offline caption provider. There are many metrics for measuring the accuracy of captions. The simplest is the word error rate, WER. For WER, every error in the sentence weighs the same. For example, ground truth. The fox jumped over the dog. With a minor error, the fox jumped across the dog. And with a severe error, the cat jumped over the dog. WER will penalize a minor and a severe error the same, based on the number of insertions, deletions, and substitutions. All other metrics consider the nature of errors and calculate weighted scores. Weighted word error rate will have higher error rates for the wrong order. ACE uses language models. It will consider the word fox versus cat to be more important than the word across and penalize the severe error more. ACE2 additionally will consider over and across to be semantically more similar, and therefore lessen the penalty compared to ACE. In our first pilot study, we compared WER and WWER calculations with participant ratings. The study had the following key findings. Users rated TV captions and 100% accurate captions from 20 clips. However, there were a weak correlation between ratings and WER and WWER metrics. 2. Users complained about the 100% accurate captions. These were surprising findings. We followed up in Study 2 to look at these issues in depth. In this study, we used a mixed methods, repeated measures design with quantitative and qualitative analysis to understand in more depth how and why users rate captions this way, and how it correlates with the 4 different metrics. We included several different independent variables and set up a counterbalanced experiment to factor for all of them. Participants saw videos with live TV captions, as well as some videos with offline human-edited captions. Participants also saw videos using the different styles shown previously, pop-on and roll-up. We also used videos from 4 types of topic contents. We also considered participants who watch videos with or without audio. In total, we had 36 short TV clips from 4 different shows. Captions from TV, Rev, and 3-play media were used, both pop-on and roll-up styles. We used all permutations of 2 caption styles and 3 sources for 6 conditions total. Participants viewed 24 out of 36 clips, 4 per condition, and we adjusted caption latency to 0 for all. We had 54 deaf and hard of hearing participants and 17 hearing participants. We calculated all 4 caption metrics, WER, WWER, ACE, and ACE2 for each video clip. Participants rated caption quality and their comprehension after watching video clips, as well as questions about their observation on caption delays, pacing, readability, errors, punctuation, and speed. Qualitative data was collected from open-ended responses, and participants also completed an English test. Zoom recordings were transcribed from ASL and or spoken English and analyzed qualitatively. Caption quality ratings for DHH and hearing people. Both groups had a significant main effect for caption source, live TV captions versus offline captions. People liked the offline captions better. There were no significant effects for style. This means that the factor of pop-on versus roll-up captions did not have a significant effect on the user perceptions of the quality. There were no interaction effects. Participants' subjective assessment of their comprehension was highly correlated with their caption quality ratings. Both deaf and hearing viewers showed similar results, irrespective of whether they listened to the sound on the video. There was no difference between the two offline caption providers, 3Play Media and Rev. There was no effect on English literacy on the results. However, nearly all participants scored highly or very highly in the English assessment. WER, WWER, ACE, and ACE2 were increasingly correlated with user ratings, but even ACE2 correlations were below 0.7. None of the four metrics was able to predict the user ratings of captions well. Hearing viewers rated TV captions worse than DHH viewers, regardless of the caption style. There was a significant interaction in three-way ANOVA. As a result, there were three categories that affected users' ratings of captions. 1. Errors. Participants were frustrated when they encountered errors in the captions. Two subcategories, accuracy and synchronity. 2. Hard to follow. Participants consistently rated caption quality lower when they found them hard to follow. 3 categories, pacing, split attention, completeness. 3. Appearance. Participants judged the appearance of the captions. 3 subcategories, placement, font, and background style. There were some limitations for this study. This included limited diversity in age and race, mostly younger and white. Also, the majority had high reading proficiency. We do not know if participants with lower reading proficiency would have had similar results or not. Also, clips had short time durations, little time to mentally correct when encountering errors. However, we found some potential paths for future work. 1. Explore content customization for captions, where users can customize captions. Would that improve ratings across the board? Do ASR-generated captions behave the same way as the TV and 100% accurate ones did in this study? Explore additional metrics, such as NER, which specifically considers editing of captions. Captions play a crucial role in making videos accessible, but creating high-quality captions that cater to a diverse need of preferences is complex. It's not just about measuring accuracy, such as using metrics like WER and WWER. Our studies showed that user experience with captions goes beyond simple metrics. Factors like latency, style, and even the presence of audio play a role in how well viewers understand the content.